Hi everyone, today I'd like to talk to you about how an engine prevents knock and especially how higher octane fuel can help to reduce soot pollution. Yes, you heard me right. A higher octane fuel can help to reduce soot pollution, also known as particulates from your exhaust. So first of all, when an engine is adapting to especially adverse conditions like high load or a steep hill, which here essentially is going to be, putting an extra load on the engine, go figure. Well, those sorts of conditions, even hot weather, that makes your engine have to work harder to avoid knock. Knock is essentially caused by the piston being forced down prematurely because the fuel is igniting and trying to force the piston back down a little bit too soon in the cycles of the engine. Lots more information out there on the internet if you're curious about knock, pre-ignition, detonation, ignition timing, octane, etc. For the purposes of this video, I want to focus on the 3 ways that an engine is going to compensate for those conditions and then expand on the topic of octane and how that also relates to particulate pollution. Okay, so first of all, when an engine is trying to avoid knock, one choice it has is to reduce the ignition timing. So to essentially reduce that advance on the spark plug so that the piston is up farther along in its stroke before the ignition starts and tries to force it back down. Now, when you do that, you can end up losing some power depending on the situation. But in the long term and in extreme cases in the short term, you're going to be protecting your engine from harm because you're not trying to make it fight against itself and force the piston down while the piston's going up, etc. So that's reducing the ignition timing. The second thing is that you can simply inject something that is going to cool off the cylinder. For the vast majority of engines, that's going to be injecting additional fuel and running rich. When you run rich, an engine in some cases can be running cooler because the fuel will evaporate, just like if you're sweating on a hot day, that's going to cool you off. Well, when the fuel is evaporating, it's going to cool off the cylinder. The problem is that unburned fuel is going to go out the exhaust, and that's going to lead into my main topic later on in this video. The third way is to go ahead and reduce the boost pressure. Now, this is if it's a turbocharged engine. Boost pressure can be reduced. There's a variety of different engine controls that can help to mitigate the boost pressure. There's wastegates, there's electronic and mechanical types of wastegates. I don't claim to know everything about all of these by any means, but that is the third way. I'm going to also mention a fourth way, and that is by you as the consumer utilizing a higher octane fuel, which then will resist that knock, that pre-ignition, and so forth. But that's not necessarily a real-time adjustment with the engine to be able to compensate for those more challenging conditions to avoid knock, pre-ignition, etc. So that would be pulling a heavy load, going up a hill, driving in exceptionally hot weather, those sorts of things. That's what tends to lead to engine knock, or ping as it's also called, because it makes that ping, ping, ping sound rapidly that sort of sounds like gravel rolling around in some engines in extreme cases. Okay, so those are some things that an engine can do. Now, if you already have fuel of a certain octane in your fuel tank and you're driving along, you're not going to be able to immediately change that. Well, that's stating the obvious. You have to wait till you fuel up again, then it has to go through the fuel lines, etc. Obviously. Now, things like the ignition timing and boost pressure, those sorts of things can be adjusted essentially in real time, especially the ignition timing. But you can only go so far because depending on other parameters, if you reduce the boost or you reduce the ignition timing, you're also going to be reducing the power output from the engine. And most consumers don't want to put their foot down on the gas only to find that it's just sort of poking along with the vehicle, especially when you're pulling a heavy load or going uphill. You don't want to be lagging behind the other traffic. So you only can do that so far. Now, with that, something that for the most part doesn't have a huge impact on overall power, but will greatly reduce knock, ping, pre-ignition, whatever you want to call it, is to inject extra fuel. Now, if you are running rich on the stoichiometric fuel ratio, it's supposed to be like about 14.7 parts oxygen to 1 part fuel for gasoline. What you're going to be ending up doing if you get too rich, the engine, it's only going to burn what it can burn. There's only so much air to use up, and if you have fuel left over after all the oxygen is burned up, well, that fuel can't burn. It can only burn in oxygen when we're talking about the regular atmosphere. So that being the case, what happens to that unburned fuel? Well, it's obviously going to go out the exhaust pipe, but it's typically converted from gasoline into carbon. And that carbon is in the form of soot and particulates. And so why is this important? Well, if you have an engine that needs premium fuel and you're always trying to run on lower octane fuels, you're going to end up polluting more with those particulates, and manuals for your automobile will typically say that you can have worse fuel economy or reduced power or performance if the octane you're using is less than what the ideal is, either as a requirement or a recommendation for your engine. So I find this quite fascinating. I was amazed to discover what an impact this makes. Now, this tends to be especially important for turbocharged engines because turbocharged engines have those higher boost pressures compared to just a naturally aspirated engine. They're also going to be more likely to require premium grade fuels, and they are more sensitive to damage from using octane that's too low, and they can overheat more easily from what I understand. And I'm looking forward to learning more about these topics in the future. Okay, so I'm going to go ahead and cut to the chase here. I used to own a 2016 Subaru Forester 2.0 XT. It had a 2-liter 4-cylinder boxer engine, and it put out 250 horsepower. 250 horsepower with a turbo, that little engine. It would very often be able to boost up to like 17 pounds per square inch or higher. It had a boost gauge that actually was on the dash that came with it from the factory. And the highest that I registered boost on that, I want to say was like 19.8. Now, obviously there can be some margin for error there, but still there was a lot of boost going through that engine. Because of how that engine was designed, and incidentally, it's essentially the same engine as the Subaru WRX engine from that time period, but with more of a focus on boost and less of a focus on the top end of the engine, the valve train and so forth. So it had to make its power more from the boost of the turbo. It wasn't quite as much horsepower as the WRX, which I think was like 268 at that time, but still 250 without the advantage of the top end that the WRX had with that valve train and so forth. It was working really hard with that turbocharger. Let's put it that way. So in the manual, it actually recommended 93 octane. That's in the United States, where AKI, anti-knock index, is used for the rating. That's the same as the RON. I think that's research octane number that's used in certain parts of Europe. So if you're in Europe, research octane number, or RON, would be 98. That's what it actually said in the manual. 98 RON or 93 AKI, which is used here in the United States. Same equivalent, 93 here, 98 elsewhere. In other words, very high octane fuel. I am not certain that I've ever even seen a pump that had 93 in the United States. 92 is what I see all the time, but 93, not so sure I've even seen it, although I do know that some places have it. I've done research on that. So why was that recommended? Basically because, from my understanding, the Subaru engine in that 2.0 XT Subaru Forester, that sporty version of the Forester at the time, which was pretty fun actually. It was kind of like a lifted WRX in a way. It was working so hard in that engine with so much boost that it needed some way to mitigate the possibility of knock in that engine. So it basically said in the manual, hey, if possible, use 93 in AKI, so in the United States. And if you can't do that, you can use 91 if you have to. And if you really need to, in other words, you can use just the regular unleaded gasoline, but be aware of this and this and this and this. Now, with that, I used 92 typically, 92 AKI. But even with that 92, I started noticing something interesting. And I had read some information online that coincided with this. I would find that there was a lot of soot coming out of the exhaust pipes. In fact, it would build up more than, as far as I recall, more than any other vehicle, at least any other four-cylinder vehicle that I've ever owned. To my knowledge, it would build up black soot inside the exhaust tips. Not a huge deal, but this part here is what was unique to that vehicle. I did a lot of in the city driving during the time that I owned that Subaru Forester, and only every so often took it out on the freeway, but most of the time it was just city driving, a little bit on some faster highways, but not much. And then when I would go to accelerate, let's say I turned onto a straight road and wanted to accelerate more quickly, I would notice a cloud of soot coming out of the back of the Subaru Forester. So I looked it up, and there is actually a video about that. You can check out the video up here, and be aware, other things can also cause similar circumstances, like if there is a leak around the intake system, turbocharger, whatever, but I kept my vehicle very well maintained. I would bring it to the dealer. There was even a recall that was looked at that was related to something similar to that, just in case my vehicle happened to have that. My vehicle passed. There is nothing wrong. So it was all good to go that way. It wasn't like there was a malfunction. And it turns out that this is evidently a common issue with a variety of turbocharged direct injected engines like the Subaru Forester. I'm not just talking about carbon buildup on valves, which is well known for direct injection engines. I'm talking about soot coming through because of that unburned fuel. Okay, so let's summarize here. With that Subaru Forester, it was, as far as I can tell, injecting excess fuel to try to cool off the cylinders. BMW, by the way, had at least one engine where water would be injected to try to cool it off. Not enough to cause hydrolock and damage the engine, but enough to cool off the cylinder without any significant adverse effects, supposedly. And that's how it could handle a lot of boost and generate a lot of power from a relatively small engine. So in the case of the Subaru Forester and certain other vehicles, excess fuel is dumped in to try to keep the power up as much as possible, but avoid that ping, pre-ignition, or knock. Okay, so let's compare that to some other vehicles. So after the Subaru Forester, I had a Mazda with a 2.5 liter turbocharged engine, and Mazda prided themselves, from at least one source that I have seen online, Mazda prides themselves in having exhaust tips that don't just get tons of carbon buildup on them. I read or saw something about how Mazda encouraged someone to look around in a parking lot at other vehicles and compare the exhaust tips from those vehicles to, I guess, a modern Mazda and see the difference. But in any case, my Mazda, it seemed like it was very clean burning. And it also had 250 horsepower, but guess what? It had that extra half liter of engine displacement. And there's the old saying, no replacement for displacement. Well, the engine was not having to work so hard and was able to therefore handle that same 92 octane that I usually used in that engine. And yes, you could use lower octane, but it seemed like it was able to handle that more. Yes, there would be reduced power. In fact, Mazda even published that the power levels were lower with the standard, the regular fuel, instead of the premium. So what am I saying there? Essentially, in my understanding and my speculation, that Mazda did things like reducing the ignition timing if there was knock, and let something like that, or perhaps turbo boost, be what prevented the knock, the ping, whatever, instead of dumping all that extra fuel into the cylinders to try to cool it off. So with that, my Ford Maverick, like my Maverick shirt, like I always like to wear for these videos these days, well, my Maverick is kind of halfway in between the two. I would say it's a little bit more sensitive to octane than perhaps the Mazda was. But my Ford Maverick definitely does not seem to just put out clouds of soot in cleaning out the engine and taking it for a high acceleration run like I would do with the Subaru Forester, where I'd clean it out in a low gear, just like wide open throttle, and just blow out all that particulate dust. Although I will say I felt kind of bad seeing that just go out behind my vehicle, and then that's out in the roadway and whatever. So note to manufacturers, if you're doing that, I suggest you take some information from other manufacturers, Mazda or even Ford, who don't seem to do that so much. So anyway, I know I kind of rambled on this video, everyone, but I will say this. In summary, be aware that higher octane fuels can at least reduce the amount of particulates that are coming out of your exhaust if your vehicle recommends and especially requires the use of premium fuels. If it only needs regular, that should mean that it's set up to do just fine as far as keeping the cylinders at the right temperature without having to worry about dumping in that extra fuel. So different vehicles are set up different ways, so be sure to read your owner's manual. And watch out for those dust clouds of carbon. Don't want those. All right, everyone. Thanks so much for watching this video, and you all have a great weekend. Bye-bye for now.